Welcome to Unacademy. Myself Sekhar, Thotakura NSC Sekhar. In this lecture, I'll be discussing about network analysis GATE-2020 solution, detailed solution. I have already discussed electrical paper as well as instrumentation paper, electrical questions. In both the papers, 10 marks have come. In this paper, in electrical paper 9 marks, and in instrumentation paper 10 marks, and in ECE paper 7 marks. Okay, I'll be discussing about the detailed solution. Okay, so these questions you can solve. They are easy questions from networks. You got easy questions. You can, if you have good knowledge, basic knowledge, not excellent, I'm saying just basic knowledge is enough to get these 7 marks in just 7 minutes. Okay, let's see. So before getting into that, let me introduce myself. Myself Sekhar. As I said, I'm a co-creator of Phasor Academy. I've been teaching, I'm in the electrical field of electrical from last 17 years almost. I'm teaching from many years, from last 8 to 10 years in different universities. Now, I discussed already different courses. I took different courses in Unacademy also. You can have a look at Unacademy. And if you like these kind of courses, first you can go to free courses, then if you like it, you can take the paid courses, and you can use this coupon code Phasor. Then you'll get also maximum possible discount. Okay, you can use this Phasor code, that can give you a discount. Okay, now coming to this today's topic, that is network questions. The first question, it's from official GATE answer for GATE question paper, officially they released. Okay, so in that question paper of GATE, question number 9, I'm taking up 1 mark question till question number 25 technical. 1 mark questions are there. After that, 2 mark questions. This is 1 mark question. Sorry guys. Okay, now what is this? In the circuit shown below, Thevenin's voltage you're asked to find. So you might be applying different techniques like for finding out voltage. There are different ways in networks. You can solve things in different ways. But right now, what I recommend for finding out any voltage, I said some rules, right? You can apply those rules in our regular courses. I discuss the rules for finding out voltage or voltage difference. Bring that rule. Okay. And here we have different sources. To make it easier, what I recommend is you convert this into a voltage source, this into a voltage source. That's the easy one. You can convert this into voltage or this into voltage. So then you will have, after source transformation, you will have this voltage source is 1 into 1, that is 1 volt and 1 ohm. Here we have 2 volt as it is, 2 ohm as it is. This will be 2 ohm and this will be here 2 ampere, 2 ohm. V is equal to I into R, 4 volt, and this stays as it is. Okay, so here current, there is no current here. I don't think you can mention this because it's not required. As there is no current, it's just simple like a line. Now this is VTH. That simple series circuit. If you find this current flowing in this, they will get it. Here 4 volts, these 2 in series 3. And minus 1, if you apply KVL also you can write it, you will get 1 by 2 plus 2 plus 5. 1 by 5 is the current. This current is 1 by 5. That is 0.2 ampere. By any technique, you can get it. Any technique, as in what are the different techniques what we have? We have KVL, or directly simply if you can answer by using Ohm's law also you can do that, anything. So now this current is 0.2 ampere. Now start here, come back to this point. Current is going this way, this is plus, this is minus. So minus 0.2 into 2. VTH I want, right? Minus 0.2 into 2, that is minus 0.4 plus 4 is equal to 3.6 volt. Answer is 3.6 C. Okay. Without drawing all this stuff, by just converting it, doing this, you will get it. Okay, it's simple one. If provided, if you apply different things here, though it is asked for Thevenin's theorem, we brought in source transformation also, because that makes things a lot more easier. Then how will you know what to apply, how to apply? By practice. Okay, we can find it as in different ways. So networks is all about finding the easiest way and the best way, quicker method. Okay. Next, in the given circuit, the two-port network has an impedance matrix. Okay, two-port network has an impedance matrix. This impedance Z is equal to this. Okay, the value of ZL for which maximum power is transferred to the load. For this maximum power to transfer, what should be the value of ZL? We know from the statement of maximum power transfer theorem, this ZL must be equal to the impedance across these two, Thevenin's impedance across these 2 points, but we don't know what kind of circuit is this. But from this matrix I can say this is a reciprocal network, because Z12 is equal to Z21. This is a reciprocal network, we can clearly say that. Okay, for a reciprocal network, what is the equivalent Z parameter, easiest diagram, equivalent diagram for Z parameters? T network. I can replace the Z network as a T network because it is clearly saying reciprocal. This value is 60. The value of this, be careful here, I'm just drawing this box into T. Okay, and the other parts will be as it is. These other parts will be as it is. Here this is there, here we have a resistance, and yeah, this is points, these 2 points, we'll have to find these two voltages, these two potential between resistance between these two. That should be the value of ZL. Thevenin's, so I can short circuit this simply, short circuit it. Thevenin's resistance, voltage source, deactivating means 0. So this is 100 ohm as it is. Now this diagram, T network, this value is 60, this value is value of this ZD minus this, these two, minus of these two, T current circuit. You should be careful with that T current circuit, that make things a lot easier. 120 minus 60 is 60. Here, careful, 40 minus 60, careful, 40 minus 60 is minus 20. Minus 20, don't get confused. As per this has to be minus 20, that's it. I'm just representing here. You may have questions now, sir, how come resistance is negative, X, Y, Z, all this stuff. See, here, there is an equivalent circuit of this. It's an equivalent representation, that's it. It's not a physical resistance, it's an equivalent one. Now, 100, and sorry, this is not 100, this is 10 ohm. See, this could have been mistake, big mistake. Minus 20 plus 10, though both are in series, the resultant will be how much? The resultant will be minus, sorry, completely got erased. Resultant will be minus 10. Here we'll get minus 10. Okay, this has gone, this is short circuit now. Minus 10 and 60, they're in parallel, and the combination will be in series with 60. So minus 10 and 60, parallel combination is how much? Minus 600 by 50. So this is 12. Minus 12 and 60, they're in series, the resultant will be 48. 48 ohm is answer. Once you know the equivalent circuit, once you apply that equivalent circuit concept, things will be easier. You can easily do that. Okay, next one. These are the 2 mark questions, 1 mark question, sorry. This is also 1 mark question, question number 15. This is also another 1 mark question, question number 16, 1 mark question. This is also easy one. The current in the RL circuit, current is given as 10 cos phi t minus pi by 4. The value of inductor is dash. Current is given, current expression is given, it is asked for value of L. Okay, so what do you observe from this? Cos, this is also cos, phi t frequency will be same, we know. Phi is equal to phase shift is pi by 4. Phase shift is pi by 4. Tan inverse of XL by R, tan phi, or I can write this way, that will be better. Tan phi is equal to XL by R, and cos phi is equal to R by Z. Okay, these two equations keep in mind. Guys, I'll be just coming up. I have a small interruption here. Just wait for some time. To change a little bit of settings. It's creating a little problem. Jaldi. Okay. Another change. Yes. It's done. Okay. Here cos phi is equal to R by Z. Okay, these were the formula we know. Now phi value is clearly given, minus because RL is there, it will be lagging. We know angle is 45 degrees. Okay, so let's keep here 45 degrees. Tan 45 is 1. 1 is equal to XL by R, so I can write from this we get to know XL is equal to R. This is the first point we got. Now Z is equal to, we know, square root of R square plus XL square. Okay, so in place of this R, in place of XL, let's put this R square. Then Z is equal to, I can write root 2 into R. In place of Z, I can place root 2 into R. Okay, now in place of this, I can place root 2 into R. Cos 45 is 1 by root 2. Cos 45 is 1 by root 2. R by root 2 R. We are getting R into R? No. Then we'll change the method. Anyways, this is, let's keep it as Z itself. Okay. Now what is this? Magnitude is 10. Current magnitude is 10. These are maximum value, these are maximum value. I is equal to V by Z, we know. I value we got how much? This is 10. For V value is 200. If it is RMS value, by root 2, both are same. By root 2 will cancel, you will get this. So from this you can write Z is equal to 20 ohm is Z from this. How I got this? I, magnitude I am taking, maximum value I am taking. 10 is equal to V by, V is this, by Z. So from this I got Z value. So this Z is equal to 20. If Z is equal to 20, we know 20 should be equal to root 2 into R. Okay. Then, or you can write directly XL also. This also can be replaced with, if I replace R with XL, because XL equal to R, let's put it this way, because our focus is on finding out L value, inductor value. So XL will give the inductor value. So I can write now, in place of R, I am putting XL. Okay, fine. So from this, XL is equal to 20 by root 2. 10 by root 2 is 7.07 into 2. Just calculate, you will get 14.14. Yeah, 14.14 is XL. So can I keep 14.14 Henry? No, it is in ohms. You need to find L value. L is equal to XL by omega. 14.14 by omega is 5. Okay, 14.14 by 5. 2.828. 2.828 Henry is answer. 2.83 can write. Okay. And any problems here? It's simple, guys. Equations, you need to go in a different manner. Directly, they are not given. Of course, GATE itself, they will not give directly. They will give indirect information. Indirectly, you should go to the formula so that you will come to the required parameters, required variables to put it in a formula, and you'll get the answer. Okay. This is also 1 mark question. Let's go to the 2 mark question. This is a 2 mark question. It seems like some students say it's like something difficult, sir, we have this and this, but it's really easy. Okay, I'll tell you, it's not just I'm saying it is easy. I'll show you how come it is easy. You need to know how to use your calculator effectively. Okay, that's it. That's the only trick here. If you know that, things you can easily understand. Okay, so you should be careful with how to use your calculator effectively. Anyways, now this current, if I take it as I1, what is given here? In this circuit, you need to find this current I. Okay, current I1 is entering here, and this current is plus is here, minus is here, so current I2, because voltage across this is the same voltage across this will be same, voltage across this will be this. So current, this voltage will drive current downward, this voltage will current drive this way. So some of these two will be going this way, but it is given this way. I is this, I is this. So this current, this current, this current, if I apply KCL at this node, I can write from this I is equal to, sorry, KCL, right? Sum of all three are incoming. I plus I1 plus I2 is equal to 0. All three currents have become 0. That's what KCL says. Now I1, what is the value of I1? Simply this voltage by Z, voltage, sorry, I am writing equal to, I1 is equal to, okay, I can write minus of I1 plus I2. I1 value is 120 at an angle minus 90 degrees divided by Z value is 80 minus J35. Okay, 80 minus J35 plus Z, this is also Z, and plus value is 120 at an angle minus 30 degrees. So I can take this as it is. So here I'll add plus 120 at an angle minus 30 degrees. Okay, I think you're able to see this. Okay, minus 30 degrees. Okay, so this is the value of I is equal to minus of this. That's it. Now you should find the value, whatever the value it gives, that's the answer. Okay, use calculator. 120. See, you can, without using calculator also you can do this addition if you have a good practice. 120 at an angle minus 90 degrees. Draw that Phasor diagram. 120 at an angle minus 90 degrees is something like this. This is a 120 magnitude, and this one is 120 at an angle minus 30, means somewhere over here. The angle between these two is 60 degrees. This is also 120 magnitude, this is also 120 magnitude. We know if two equal magnitudes are displaced by 60 degrees, the resultant addition of these two will be √3 times of this. We know that. √3 times of 120, and this angle is 30 degrees. Okay, so from the reference it will be 60 degrees. Okay, if you don't have all these analysis, you need to use calculator. Once you have a good practice of it, you will get all these points. So the resultant one, this I can write with our experience of practice, or you can say anything, 120 into √3 at an angle minus 60 degrees. Okay, by 80 minus J35. So now you need to solve this. Okay, there are again two methods for this. The easiest, the possible method for GATE. For GATE, you should convert this into polar form, because answer is given in terms of polar form, and it's a division. For division, you have to convert things into polar form. So convert this into polar form. Okay, let me do that. 80 minus J35. If I convert that into polar form, you will get this one as, this polar form you will get it as 87.32 at an angle minus 23.63. Okay. Now, see here guys, another interesting point. 120 by √3, another interesting point I am giving here. 120 by √3, so I value you will get it as minus of 120 into √3, not 120 by √3, 120 into √3 by 87.32. I am writing that 120 √3 divided by 87.32. We'll get the value of 2.38 minus 2.38 at an angle minus 60. In the denominator we have minus, if it go to numerator it will be plus. 60 plus 23.63. 60 plus 23.63. Sorry, minus 60 plus 23.63. Because this is minus 60, right? Here minus 20. If it goes to upwards, you'll get plus. This is minus 36.37. This is answer. We got the answer, right? But look at the options. Any option is matching with it? No option is matching with it. Not, first of all, it's not minus. Then have we done something wrong or something? No, it's not that we have done something wrong. This is a different representation. This is, we have one representation, this is represented in a different way. Phasor representation, you should know all possible representation of phasor. So what is this representation and what is this representation? So this represents, this is representing, suppose this is a reference. With respect to reference, some length is there and minus, this is minus 36.37, that is what given. And I'm talking about this represents only this part, not a negative part is not included now. This highlighted part is this phasor. 2.38 is the length and minus 36.37. And you need to take minus sign to this, means what? This will turn exactly 180 degrees. So this is the final vector. This is a final vector with same 2.38 length, and this angle will be how much? 180 subtract 36.37 from 180. Then you will get 143. 180 plus minus of 36.37, you will get 143.63. So answer is C. These are only tricky part, you should be careful. If you know how to draw the different, how to get the different representations of this phasor diagram, then things will be easier. Okay, easier as in things will be understood, things can be answered. Okay, otherwise it will be tough. Okay, now the last question. By looking at this, you might be thinking, so this is something out of the box. It is state equations, so it's closely related to control systems because state space analysis is there in case of control systems. So you might relate with control systems better, but it's not much of involvement. There is no much control system involvement is there. With networks knowledge also you can answer this. I repeat, with networks knowledge also you can answer this because it's after all equation. It's after all equation, right? State space equation is after all equation, mathematical representation of this. It's a circuit, electrical circuit. We know how to draw the mathematical equivalent for an electrical circuit, okay, from the networks concept only. Now let's do that. So here, if you see, all are given in terms of d by dt v, d by dt I. So dv by dt, di by dt means this inductor, rate of change of voltage, rate of change of current, means we know I is equal to, or V is equal to L di by dt, this one, and this is a voltage across this, and this for this current I is equal to C into dV by dt. Okay, so here you want this current, for this you need this voltage, because this voltage will give us derivative of current. Okay, so write the KVL for this loop. Write the KVL for this loop. Simple. Write the KVL for this loop. What is the KVL for this loop? First loop, if I take current, this is I1. Okay, I1 is entering here, I is leaving, so this current must be I1 minus I. I1 minus I. So if I write the KVL, minus I1 minus I into 2 plus VL is L di by dt. Voltage across this is what? L di by dt. L value is 0.5, so I can write directly 0.5 di by dt. Okay, let me just bring it down so that it will be clear for you. Di by dt, then plus V is equal to 0, this voltage. KVL is done. This is the first equation. Now simplify this. This is one equation we got. First simplify this, then let's see if that is matching. Then we don't have to go to the second equation, directly we can answer it. Let's have a look at this. We should write in terms of di by dt. Okay, let's put it that way. Di by dt, from this I can write it as, take all other things to the other side, you will get 2i1 minus 2i plus v. 0.5 into di by dt is equal to this. So 0.5 I multiply, here you'll get 4, here you'll get 4, here you'll get 2v. Am I right? 0.5. Okay, sorry, if you multiply with, what am I doing? Am I doing something wrong? Yeah, that's right. Divide, here it is multiplication. Once you go to division, then 4, 4, 2v. That's fine. So what is matching? Any match? So if I just write in this form, I'm just shuffling this. 2v minus 4i plus 4i1. 2 minus 4 plus 4. 2 for this di, the second row I'm talking about. Plus for this, if I put it in the matrix form, here you'll get 2. Minus is there, minus is there, minus is there, minus is there. All are having minus. Then we have done something wrong, obviously, man. If it goes to the other side, it will be minus only, right? That's my fault. You should have told me. If it is a live class, yeah, I would have said it. Because there is a plus v here. If it goes to the other side, it will be minus. And the other thing? Yeah, fine now. So minus 2, all are having minus 2, no help. Then minus 4, these also minus 4, this no minus 4, this cannot be the answer. Minus 4, these are also minus 4s. And here, plus 4 is there, plus 4 for I1, plus 4 for I1. Here I1 is, sorry, this I1 is plus 4, so this can be the answer. Here also plus 4, here 0 is there. I1 coefficient is, if you multiply these two, you will get 0. So this cannot be the answer. So either this can be the answer, this can be the answer. So we will go to the next one, it will be done. Okay. Next equation is for this dv by dt. For dv by dt, we know this is dv by dt means I by c. I repeat, dv by dt means I by c. So we want to write current equation. So I am writing KCL here. If you apply KCL to this node, then I2 is coming. Here. Here this is V. So here current in this also V. There are different ways again. Okay, this is not the only way. There will be different ways. This is the current V because voltage across this is V. So current flowing in this also will be V by 1. I is equal to V by R. V by 1 is V ampere. Okay. And this current is I is equal to IC is equal to rather C dV by dt. So if I apply KCL, I take these two are leaving, this is entering. So I2 is equal to, I write one now. I2 is equal to V plus IC. So IC value is C dV by dt. Instead of writing IC, let's put C dV by dt because I want in this form, dV by dt form. Okay. So C value is 0.25. I2 is equal to V, that's fine. Now take it to the other side, dV by dt is equal to, if you just rewrite this equation, you will get dV by dt is equal to, what will you have? Minus V plus I2. 0.25 dV by dt is equal to this. If I take 0.25 to the other side, minus 4V plus 4I2. Okay, so out of these two options, again I missed something here. What is that something? Because minus 4, I value also here, right? I value also here. Did I miss something more? Give a check. I2 is equal to, this is the current, this is the voltage V by 1, fine, perfect. And this current is is equal to IC if I take, okay, that's fine. IC is equal to C dV by dt, that's fine. C value is here, dV by dt, we done it. How come? Let me just give a thought. Let me just give a thought. If you can figure out the point, you can say -4 is there, so from this I can directly say this answer. This is not the answer. 4 -4 -2 -4. This is the answer. This cannot be the answer because for I2 also we have this, but this is not matching. This is also should match. Okay, let me just check. Give me some time. Question number 30. What is the answer they are given? A is right. A is right, but somehow we got this match. This got matched. This not matching. Oh yeah. Okay. Sorry guys, yeah, that's a point. I applied KCL here. When I applying KCL here, I just consider these two. That's a bloody blunder. 1, 2, 3. Degree of this node is 4. 1, 2, 3, and 4. This is also there. I should consider this current also, right? I should consider this current also. That's what? This is also incoming. I2 is also incoming. I is also incoming. So plus I. Now fine. Now fine. Now you'll get plus 4. Fine. Plus 4i. These are KCL. Let me rewrite. These are KCL at this node because we have 1, 2, 3 and this 4 elements. So this is incoming, this is incoming. I plus I2 is equal to V plus this current. This is done. Now dV by dt is equal to, from this we can write dV by dt is equal to dV by dt is equal to 0.25. if we keep it here, then minus V plus I plus I2. 0.25 take it to the other side, you will get 4 minus 4 plus 4i plus 4i2. Okay, yeah, now this is the answer. That's it. That's it for this. The other questions from GATE 2020. There is no much difficulty question, which has arisen. You need to just bring the concepts into one place. Simple concept also, not a big difficult concepts. Okay. See you in the next sessions. Stay tuned. As I said, if you want to take the courses plus courses, you can use this coupon code. Okay, so that you will get maximum possible discount also. Okay, different courses are available, different plans are available, monthly plan, 2 months plan, or yearly plan. Okay, so for any plan you can use this code, then you will get a discount also. That's it. See you in the next lecture.